True.
Okay, so this is a chapter on indices.
Okay. So that's the one with the squares cube
Yeah.
to the power of x, y, z.
Yeah.
Okay.
So for example,
10 to the power of 3 is a indices,
Okay.
right?
let's use 10 to the power of 3.
Mm-hmm.
So 3 is an index.
Mm-hmm.
Okay, the plural of index is indices.
Okay.
10 would be known as the base.
Okay.
Okay, so this chapter is about manipulating indices so that you can simplify your expressions.
So basically, it's using the small created index or indices to basically make what would otherwise be a very large, very long number into a small number.
Yeah, in the practical world, we will use indices to make numbers look nicer,
Okay.
easier to understand. There's a certain sophistication when it comes to math in terms of numbers. So numbers look neater when they are expressed in terms of their indices or in their prefixes, as you've learned in physics.
What?
Prefixes like
Oh,
kilometers,
okay. Kilo, tera,
mega,
mega,
giga. Those are prefixes.
Yeah. On the topic of physics, right? It has been confirmed that we will use digital vernier calipers.
Yeah, that's good to know. All right.
Yeah, as I was saying, the syllabus change.
Okay. Okay. So for this one, the first example, the first concept, am times a the power of n. Okay. Since you have used the example of 10 cubed over here, I'm going to bring that in. So an example would be 10 to the power of 3 times 10 to the power of 5.
So that would be 100 to the power of 7. No, sorry, to the power of 8.
That would be 10 to the power of 8.
10 to the power of 8.
That is 3 plus 5.
Okay. Well, let's say it's
Okay.
11 to the power of 3 times 10 to the power of 5. Would it still be?
No, it has to be the same base, a and a.
Okay, well, what if it's A and B?
Then you have to evaluate it normally.
And then put it through a calculator.
Yeah. If it's an algebraic term, then you cannot evaluate it.
Then how do I do that? Just leave it as it is.
Yeah. So example, if you are talking about algebra, then it will be x cubed times x to the power of 5, and that will give you x to the power of 8. If it's a different base, x cubed times y to the power of 5, then it will just simply be x cubed y 5. Okay?
Okay.
So that's for multiplication. If we are dealing with division, then the opposite applies.
We're subtract.
Yeah. So you will, if you take 10 to the power of 3 divided by 10 to the power of 5, you will get 10 to the power of
minus 2.
minus 2. Okay? Now, this can be expressed into 1 over 10 to the power of 2 because of the minus sign. So that is coming from rule number 6. This is the law number 6 over here, where a negative index would give you an inverse in terms of the fraction. So basically, what it means is 10 to the power minus 2 can be written as 1 over 10 to the power 2.
Oh, okay.
Yeah, that's simply what it means. So it's easier to understand the laws when you're dealing with numbers, because numbers are something you have worked with for many years. So to first understand the law, you have to understand using numbers.
Okay, that makes
Simpler
sense.
that way. All right.
Yep.
Okay. So this is again, it if you are dealing with algebra,
Mm-hmm.
the same thing applies. X cubed divided by x5.
And I have x to the power of minus. Well, no, I would have 1 over x to the power of 2.
Yeah, or x to the power minus 2. That's fine.
Okay. Okay, generally speaking, right, which one do I use more often? The non-fraction or the fraction?
Both. You will encounter different kinds of situations. So
basically, my teacher could be using the fraction to throw me off, and I'd be there scratching my head like, how the hell to do this?
yeah,
When really,
you could very well be dealing with both in the same question.
okay.
Okay? Can I move on?
Yep.
Now, the next one, law number 3,
Mm-hmm.
is when you have brackets. So let's bring that in.
There's a mark.
A the power of m
Mm-hmm.
bracket power of n.
Mm-hmm.
So let's give an example. 10 cube
Mm-hmm.
bracket square.
Mm-hmm.
So instead of adding the index, you've got the times. So if you see a bracket,
Uh-huh.
you've got a times. So it's
So
3 times 2, so 10
10.
about 6.
Okay.
Okay.
There is no fractional equivalent for positive indices, right?
What do you mean by fraction?
Like 10 to the power minus 2 can be written as 1 over 10 to the power 2. Is there a version of this for positive indices?
Yes, you can. Then you just do the reverse. So
So-
10 to the power of 2,
Would be 1 over 10 to the
1
power.
over 10 to the power minus 2.
Oh, okay.
Yeah.
This one is seen less often, right? This one.
Yeah, it's not very practical. Usually people do it the other way around.
Okay.
Okay, so similarly, if you have algebra term,
Uh-huh.
so x cubed and then bracket square, and that will give you x the power of 6, 3 times 2. Okay? Now, since you've been thinking about negative powers,
Mhm.
negative index, so let's try x the power of minus 3
Mm-hmm.
bracket squared. What do you get?
X. Oh no. What 1 over x to the power of 6.
Yeah, x to the power of minus 6, which is then 1 over
One
x to the power of 6. Okay?
Mhm.
Okay. The next one, rule number 4, law number 4. Am multiplied by b the power of n. Okay, in this case, because the index are the same but the base is different,
Okay.
so you can actually group the index. You could group the index together, so you will get ab bracket power of n. So an example would be 10 cubed multiplied by 5 cubed. Okay, and that will give you n times 5, the whole thing bracket cube, and that will give you 50 cube, because 10 has a cube, 5 has a cube, so you could group them together with the same power, the same index, and therefore you can put 10 times 5 bracket cube, that gives 50 cube. Now, if you're not too sure, you're like, is this real? You could actually use a calculator, calculate out and see if you get the same answer.
Okay.
All right, so that is for law number 4.
So to summarize, law number 4 basically says that 10 to the power of 2 times 11 to the power of 2 can be done as
10 times.
110 to the power of 2.
Yeah,
Okay.
Yeah.
That's law number 4 is true.
yeah.
Okay. Can I use smaller numbers for that example?
Whatever numbers work for you.
Okay, so 1 googolplex to the power of 2. Just 2 googolplex to the power of 2
What?
should equal to yeah, do you know what a googolplex is actually?
It doesn't matter, man.
It's got
What
100 zeros.
Yeah.
So 101 digits. So
Why would you want to confuse yourself?
I don't know.
You're learning something new, you're like, let's put more numbers inside. I can understand that way better if I put in bigger numbers.
Honestly, it should be the complete freaking opposite.
Yeah, that's what I mean. Okay, law number 5,
Mm.
right? A over B power of n can be rewritten as A the power of n divided by B the power of n. Again, this is one of the common questions that you may see. So let's explore it. Example would be 2 over 5,
Mm-hmm.
the power of, let's make it a cube.
Cube.
2 over 5 bracket cube
Okay.
is then equal to 2 cube divided by 5 cube. Okay,
Okay, that
so
makes-
meaning to say that if they are both under the same bracket, with the same index, you can split them up with the same index.
So a to the power a over b to the power of c would equal to a power c divided by b power c.
Yeah,
Okay, that makes sense.
okay. So number 6, we have gone through it, negative index, that's settled. All right. Let's take a look at number 7 now. Anything to the power of 0 is 1.
So 1 million to the power of 0 equals 1. Huh?
Yeah. Okay, this is very straightforward. And you can prove it.
Okay,
Okay.
sure. I'm gonna put this in to the power of 3. And before that, in brackets, I'm gonna put that the power of 1 should equal to 0. No,
Okay.
it did not.
Can you take a look at the screen?
Yeah.
See how it's being proved? So a the power of 0
Mm-hmm.
can be rewritten as a the power of say 2 minus 2. Okay, because 0 can be 2 minus 2, can be 3 minus 3, can be 100 minus 100, it's fine. You can express this into like so, a squared over a squared, because we are applying law number 2. 2 minus 2 can be expressed as a squared over a squared. And if you cancel it out, you get 1. Okay? So that's for law number 7, and it's a very common question that comes out. Be aware.
Okay.
All right, we're almost at the end. So hang in there.
Barely,
Okay.
barely alive.
You're almost at the end, man. Come on, chill. Okay, a the power, law number 8. A the power of 1 over n can be rewritten as n root a. Okay,
A
so
to the power of n can be written as n root a.
a the power of 1 over n. So let me explain. Again, with numbers. Work with numbers is easier for you.
Mm-hmm.
Let's say 100 to the power of 1 over 2.
Okay.
Okay, so 100 to the power of half, basically. 100 to the power of half can be rewritten as square root 100.
Yeah. How does that make sense?
Because if you use the law, it makes sense.
Well, the law doesn't make sense. It's unconstitutional.
It's a law of indices.
So,
That's how it's written.
what came out of this law?
Yeah. You gotta get used to the law, man.
It's unconstitutional. I still don't understand it.
How should I put it? Okay, think in terms of this. If I ask you what is 2 squared,
That's 4.
that's 4. Okay, but no, let's use that way. If I ask you what is 4 squared,
Yeah, we're gonna stand up for this.
that would be
4 squared is equals to 4 times 4, which equals to 16.
what about 4 to the power of half then?
That's equal to, well, 8.
No. Okay, so if you think of it this way, if 4 square is 4 times 4,
Uh-huh.
4 to the power half is the opposite of 4 square. So instead of squaring it, you have
would be the
to
root.
square root it.
So equal the square root of 4.
Yeah. Which is 2. So that's how it works for this law. Okay.
Then you give me another one so I can write it.
All right. What about 9 squared?
9 squared is 81.
What about 9
9
half?
equals the square root of 9 equals to 3.
Yeah.
Right.
Okay.
Okay.
So think of it as the opposite. When you see a fraction of an index, it's the opposite.
Fraction of index is opposite.
Yeah.
Of a regular index. Right. Okay, but then what about 4 to the power of a third?
That's a good question.
Wait, no, it's a third, so it should be the cube root
Yeah.
of 4.
Yes. Now you got it.
So if it's 9 to the power of 1 over 102, then it'd be the 102
Yeah.
root of 9.
Yeah. 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 That's right.
Okay.
And you got to key into your calculator. You can actually get the answer out from there.
So the 100 is, wait, how do I read this? The 102nd root of 9. I know there's a way to do it. I think it's like this. No,
Yeah.
that's 3.
Don't worry. I'll work with you later on that.
Okay, I got it.
On how to key in the calculator.
I got it. There's 102 root 9. Goes there.
Yeah. Okay.
Sure.
So now you got it. Okay, since we are on that, since you are on the roll, let us do number 9 together. So we're going to combine everything. Now, what is 27
Yeah.
to the power of 2 thirds?
Yeah.
Okay, so now you have the numerator and the denominator. Okay,
Well, it would probably be.
so what you can do, you can apply, yeah, and then you put it.
Wait, is it like this?
That's right.
Because I think you told me this before.
Yeah.
So I just have to punch that into my calculator.
No, stop. You can't do it. You can't calculate this directly from calculator. You show the working. Because a lot of times you are required
Just
to.
show.
Yeah. So you cube root 27 first.
Okay.
What
So
is that?
that's what times what is 27.
Yeah, so you gotta know your cube roots.
3 times 3 is 9. 9 times 3 is 27. So
Yeah.
3.
Yeah.
Equals 3 squared.
Yeah.
Which is 3 times 3 is 9.
Correct.
So therefore,
And that's the answer.
27 to the power of 2 thirds equals 3.
Yeah, so you have to show it exactly what you are seeing right now.
Okay.
This is what I mean by working. You can't just put in calculator and give the final answer.
Okay, so
You get no marks for that.
so a to the power of x over y equals to what x root of a to the power of y.
Right.
Okay, that seems easy enough. So let's say a to the power of 53 over 5 would be the 53rd root of 5, all of that squared.
Yeah. 5. No.
Why not I cock it up?
It's 5 root a.
5 root of a
5 root a to the power of 53. Yeah.
Oh,
Okay.
so it's okay, it makes sense. So basically you're doing okay, I get it. So basically because the A and the 5 are slightly lower or slightly on the same level compared to the A and the 53, therefore the 5 is the root of the A and the 53 just does its thing, right?
That's the thing.
Does its thing as given the scope, right? That makes sense.
Yeah. You gotta explain.
We have to explain it.
I mean, most of the time you'll be asked to expand something. So we look at some examples from here
Oh,
to give you a better idea.
expanding shit like this.
Something like that.
Well,
Like you didn't really have to say shit on the video. Or
Oh, I forgot it's on record.
now everyone knows that you say shit.
Yeah, I need to fix my sensor. My sensor is a problem.
You have no sensor, what are you talking about?
I had a sensor when I came back. I was scold people for saying the F word. Now I don't.
Well, I guess you've changed over
Yeah,
time.
I've changed. It's like